Good morning student. Today we will discuss about the simulation of Nand gate using Microwind software. Okay. So this one is the circuit for the Nand gate. Now in the Nand gate, to input Nand gate equation is y is equals to a dot b bar. So how is the connection? In the pull down network we will connect two NMOS in series, and in pull up network we will connect two PMOS in parallel. Okay, so how to make the series connection? So when the drain terminal of one MOS is connected to the source terminal of another MOSFET, then it is called as the series connection. And when both the drain terminal of both the MOSFET or the source terminal of both the MOSFET are connected together, then it is called as a parallel connection. Okay, so now here if you see the circuit, the drain terminal of first NMOS is connected to the source terminal of another MOSFET. So it is the series connection. Source of the first NMOS is connected to the ground, and from the drain of second MOSFET we will take as the output. Similarly, in pull-up network, both the drain terminal of PMOS are connected together, and here we have taken the output, and both the source terminal are connected together, and here we are supply the VDD, and input A is applied to one P and NMOS, and input B is applied to the another pair of P and NMOS. So this is the circuit, and now we have to simulate this circuit using the Microwind software. Okay, so we will open the Microwind software. Now here there is a NMOS generator, so we will take on the NMOS. Now we require two NMOS, so here we will require two gates, so number of fingers we will take as a 2, and the we will generate device. Here the MOS is generated, 2 NMOS is generated. Okay, we will take this, for example, this is source, gate and drain, and we can say this is the source, gate and drain of another NMOS. Or we can take this as a source, gate and drain, and this one is as a drain, gate and source. According to your requirement, your circuit, you can take the drain as a source and source as a drain. So we have taken two NMOS together, then we will take the two PMOS together, generate device, and we will take the two PMOS together. Now using alignment, stretch and move, we will align both the MOSFET together. So here we have align both. Now we have to connect the gate terminal of both the MOSFET together. We will take the polysilicon. So one PMOS and one NMOS are connected together. One PMOS and one NMOS are connected together, gate terminals. So input are connected. Now if you see the circuit pull down, the source terminal PMOS are connected in the parallel. So what we have to do? We will connect, suppose this is the source and terminal of the PMOS and NMOS together. So we will connect this both source terminal together. So this become parallel connection. So this one become the drain terminal of both the PMOS. Now here there is a series connection of NMOS. So we will take this as a source. This one is drain and this is gate. And this is what we take, drain, gate and source. So this is what we take as a drain and source connection. So this one is the series connection. So this is the source terminal of our first MOS. So we will connect it to the ground. Now we will supply the VDD. So VDD, source of both PMOS are connected to the VDD. In order to avoid the floating, we will connect the VDD to the N-well also. Now output is taken across the drain terminal. So we will select the metal one, and this one minute, I will take the metal one. Okay, and we will connect this metal one together. Now here, as the gate is made up of polysilicon and the source and drain terminal is made up of metal one, so it is overlapping, it is not connected together. So this is our circuit. Now we will apply the input clock. So clock, suppose this is our input B, so always input B is M, for example LSB, and input A is MSB, so always apply the LSB first because it is somewhat slower. Okay, clock. So we will assign first the LSB and then MSB. Okay, so MSB on the second input. So input A. So we have applied the clock, and output we will observe on the visible node. So here on the Y is our output. So these are the drain connected together. So here output is observed, and then we will save our circuit. So we will give some name, Nand 3 for example, and we will save this, and then we will run the simulation. So this is our output, we can observe. So for example here, when the input is the high, both the input is high, our output is low. Okay, so this is the NAND gate simulation. From the here input A is what we can say, input A is high and input B is high, then and then our output is 0, otherwise our output is 1. If you want the rise time, fall time, select on this and click on the reset, and you will get the rise time, fall time. If you want to simulate with the capacitor load, go to the palette, select the capacitor, place on the output, assign it, and again run the simulation. We will get the output with capacitive load. Okay, so this is about the NAND gate practicals, simulation of NAND gate using